A few chapters ago, we talked about solving systems of equations. We talked about 3 different ways we could do that. We could do that graphically by graphing both linear lines and seeing where they intersected. We also use substitution or elimination. What we're going to be doing in section 10.3 is we're going to be solving systems of nonlinear equations. So all those equations that we've been talking about in the first 2 sections. What you see in front of you shows kind of visuals of what we're kind of talking about and how they're applied. So in this first one right here, we have an ellipse and a hyperbola. And you can see that they meet at 4 different places. Therefore, there would be 4 solutions, an x and a y, for the system of these 2 equations together. The one on the top right is a circle shown with a line. Now, the line only intersects the circle at 2 points, so this one would only have 2 solutions. Now, this doesn't always have to be 2 solutions. This could technically only pass at exactly 1 point, so there would only be 1 solution, or a linear line could not pass at all, and therefore would be no solution. Again, same thing with the first one. Depending on how you turn the ellipse or where the ellipse is placed would determine how many solutions. And finally, we see in this third one, parabola with a linear line where it intersects at 2 places. In our first example, we have a system of x squared minus 2y equals 5, and we have x plus y equals negative 1. Sometimes it helps to kind of think about what kind of equations we're actually using right here. The first one has an x squared only in one variable, so this would imply a parabola. And then this one right here, x plus y, this is just a linear line. What I'm going to do for this one is I'm actually going to solve this by substitution. So I'm going to get x or y by itself. Either one would be fine. And what I'm going to do is I'm going to take negative 1 minus y, and I'm going to substitute it for that same variable in the other equation. So what we're going to have is negative 1 minus y squared. And then we're going to subtract 2y, and that's going to equal 5. Again, that brings the equation down to one variable and allows me to solve. Since this is a binomial, I'm going to FOIL. That's going to give me 1 plus 2y plus y squared. Drop down the negative 2y, and that's going to equal 5. Since this is a quadratic, I'm going to bring everything to one side. And this is factorable, so I'll factor this. And you'll notice I get 2 solutions. I get y equals positive 2 and y equals negative 2. What I'm going to do is I'm going to take each one of these and plug it into the equation to find out what x is. So x plus y equals negative 1. I start with the 2. X plus 2 equals negative 1. Therefore, x equals negative 3. So my first solution will be negative 3 comma 2. X being negative 3 and the y being 2 that I plugged in originally. I'll do that again. I'll do x plus a negative 2 this time equals negative 1. Therefore, x equals 1. And now my solution for that is going to be 1 comma negative 2. So I get 2 points at which they cross. If we were to graph both of these, again, that's where those intersections would occur. If we look at number 2 and look at what kind of question or what kind of equations they are, the first one would be a circle and the second one would be a linear line. I'm going to do a very similar process by getting a variable by itself and then substituting it into the equation. So we're going to get 4 minus y squared, and then we'll add it to y squared equals 1. When we go to FOIL that, that's going to be 16 minus 8y plus y squared, and that's going to equal 1. Oh, forgot the other y squared. Plus y squared, and that equals 1. So now I'm going to bring everything together. 2y squared minus 8y plus 15, and that will equal 0. Now this right here is a quadratic, but it is not factorable. So what I'm going to do is I'm going to use the quadratic formula. negative b plus or minus b squared, which will be 64, minus 4ac, all divided by 2a. And what you're going to get is you're going to get x plus or minus square root of 64 minus 120 over 4. And we'll get x equals 8 plus or minus square root of negative 56 over 4. Now, what you'll notice right away, hopefully, is that the square root is a negative number. That would imply that's an imaginary number. So, therefore, since it's not going to intersect, we would actually get no solution for this. And this brings us to our last example of the day. We have x squared plus 3y squared equals 21. That's going to be an ellipse if we kind of work it out a little bit. And the second one, x squared minus y squared equals 1, is a hyperbola. Now, what's different about this one is you'll notice that both equations have x squared. So this is actually going to make it pretty nice to use elimination, because you'll notice the x squares are the same. So what I'm going to do is I'm going to subtract this quantity right here. X squared minus x squared cancels out. This gives me 2y, sorry, this will actually give me 4y squared because the double negative equals 20. Divide by 4, we get y squared equals 5. And then I will get y equals plus or minus square root of 5. So again, I get two different y's. I get square root of 5 or negative square root of 5. And I'm going to go back and I'm going to go ahead and plug it in. I'll use the bottom one since it's a little bit easier. X squared minus square root of 5 squared equals 1. X squared minus 5 equals 1. X squared equals 6. X equals plus or minus square root of 6. So let's think about what that means. X also generated two solutions for this. So this will actually give us two types. Square root of 6, comma, square root of 5, and negative square root of 6 and square root of 5. So there's two right there. We're going to do the same thing with negative square root of 5. So it's x squared minus a negative square root of 5 squared equals 1. This pretty much gives us the same thing. So x equals plus or minus square root of 6. But again, this is going to generate two more, which would be square root of 6 comma negative square root of 5 and square root of 6 comma square root of 5. Which, if you think about it, would be possible if I have a hyperbola and an ellipse. They can cross at 4 different points.